Yeah, good morning, Ananda. Topic is advanced structure modeling. This is Dr. V. Hari Krishna, working as assistant professor at Mallaradi Engineering College. And what is advanced structural modeling? See, whatever the classes are there, whenever we are describing the structural features to the objects and classes with the operations, then that is called as advanced structure. Whatever in the advanced structural modeling, what are they implemented? New operations, what are they implemented? New attributes, what are they implemented? We can see a model always we are having some instances, okay, and classifiers, operations, and attributes. Then what are the UML classifiers? See here, the shape here. Whenever we are taking a class, that is a type of shape. The shape is containing of what is it is a type of oval or it is a diagonal or a triangle, that. And what is it is origin, what is the mode, we can say here how it is going to be displayed. I know process, for example, this is taken as a process. This is the process symbol, then it is called as a process loan, and this is called as a kernel, custom service subsystems, this component, okay. This is node, this is component, this is node, this is process, okay. This starting, and this is toolbar. They're all how this is all going to be visibility. Means whatever the data we are having, the objects and attributes and classes are going to be mentioned in the structural format. Then that is called as structure. A scope is nothing but the instance. For an instance, what value is held by your classifier, then that is called as a scope. Then what is the classifier? Future of instances, that the classifier will classes the features of the instances, what type of the in how many instances it is going to be work done, that all the things are going to be taking place. There is just one value of the future for all instances of the classifier. Only one value is there for all the instances of the class. For example, if you take an abstract class, no instances are there. Concrete class as instance, all operations are implemented at one time. Abstract operation, no implementations are there. Root class, no parent is there. Leaf class, no subclass are there. Leaf operations cannot be overridden or redefined by subclasses. Polymorphic operations can is nothing but overridden or refined by subclasses. These are is a diagram we taken here. Icon root. This is again icon. This is going to be transferred to the component. Then it is going to be a rectangle model. The button, if we by clicking here, it is going to be transferred here. Then root. Again from abstraction to we get in the root. Okay. Then it is going to be checked from the root only. Then next going to what is how many class instances are there? Means how many times the data is going to be executed. That the number of times is going to be how many instances that is going to be implemented. Then what are the elements are there? Okay. Then we have to specify the attributes. We have to install the values. Okay. What type of the attribute? Okay. Whatever the attribute, the name of the attribute we have to mention. Then operation we have to mention. Then again we have to mention the operation. Then we have to mention the parametric representation. Then what is going to happen? See here, association class. One class is associated with the other class, then the class is called as association class. The company is going to associate with the person, person is going to be associated with the company. Then we have to link association link 0 to 1 many. Company is one company and persons are 1 to many. Relation. Relation is nothing but a semantic relationship between the classifiers in which one classifier specifies a contact that another guarantees to carry out. Means only one contact to another. Okay, not more than that. That compulsory it carries the output here. Realization means where it is going, that the symbol is nothing but this one, how it is going to account balance rules to the I rule agent. Okay, the realization is going done. Next component realizations are interfaces like this, interfaces like this, component this is the component diagram, interfaces like this. Use case nothing but the validate user, validation analysis, validation design. First, we have to validate the value. Then by using the interfaces, we are collecting the diagrams. We are making a diagram, use case diagram we are having, class diagram we are having, sequence diagram we are having, component diagram we are having, deployment diagram we are having. The interfaces are going to be mentioned like this. An employee we are taking, employer is like this. These are the interfaces are going to be taken places. What is in a package? Means organizing the animals into a group, we can take the package here. The package diagram is going to mention like this. The package organization of the group of employees. For example, here taking my employee means group of employees into the one organization. Okay, the client to the policies falls with the graphical. Number of policies are there, number of clients are there. Clients, a client is using one policy. From number of policies, number of client, any one person is going to be one policy, then that is going to mention outcome by the graphical user interface. See, this is also what we are taking all this interface component. All the diagrams are going to be mentioned here. We specified a diagram, payment schedule management, how the payments are going to bank in the bank, buyer's invoice management, then payment is scheduled. If it is no, the amount is not going to be transferred. Again, account management, we are going to take in places. In the account management, again, we can check that is going to be happened or not. Okay. It's about the structure model. On the structure model, we have the use case diagram, class diagram, component diagram, deployment diagram, activity diagram. All the diagrams are there. Okay. Thank you. Tomorrow we will see another model diagram. From we will start from the use case.